Greetings, detectives. This is Mrs. McKay, and we're ready to move on to a new method on how to solve systems of equations. And this time we're going to learn a method called elimination. So go ahead and write in the learning target clue, I can solve a system of equations by elimination. Now, before we do anything else, let's go ahead and quickly review what we've learned so far. We know that a system of equations has two or more lines. Typically, what we do in this level of our class is we only work with two lines, but when you move up into higher math, you actually will solve systems with more than one line, or more than two, sometimes three or more. But for our situation, we're only basically using two lines, and it's two lines, and if you remember, a line has an x and a y. It has two variables, and that's because a linear equation is graphed on a coordinate plane where there's an x and a y. And so when we have two linear equations that have two different variables, an x and a y, we're looking to see where those two lines intersect or what point they have in common. And we've learned two ways to do that. The first way we do it is we graph. We graph each line and we actually look and see what is the point that they intersect. But we found that sometimes when we do that, it's not so easy to pinpoint the exact point on the coordinate plane unless we have a very, very detailed graph. When we start dealing with fractions, it just becomes nearly impossible, and we have to be very, very accurate. So we learned a new way to solve a system of equations, and that was using substitution. And substitution would take something like we get one of our variables isolated, like we say we isolate the x and we say x equals 2y plus 1. And then in our other equation that might look something like this, 2x plus 3y equals 4, we take the x, whatever x is equal to, and we plug it in. We substitute it for the x in the other equation. So those are the two ways that we've learned so far, graphing and substitution. And today we're going to learn a new way, and that's called elimination. And elimination is my favorite. It's my favorite way to do it, but even elimination doesn't always work. But again, we're looking for different methods and different ways of doing it. And I guess the reason I like elimination is because you actually are sort of like a magician and you make something disappear. The goal of elimination, and you'll want to write this down, the goal of elimination is to get rid or eliminate, get rid of a variable. Okay? We know that we can't solve equations when we have more than one variable. So we know that we have to get that one variable isolated. And if we can have everything else just be constants, then we can actually solve for that variable. So our goal then in elimination is to completely eliminate or get rid of one of the variables. And then we solve for the one that's left behind. Once we know what one variable is, we can then go back, plug it into an original equation, and find out what the eliminated variable is. So let's go ahead and look at my steps to solving systems by elimination. The first thing that it says to do is to line up the two equations so that the variables and constants match up. So let's look at my first problem here. It says solve using elimination with addition. So here I have 3x plus 4y equals 12. Then I have another linear equation, 3x minus 6y equals 18. Now these equations are in standard form, which is perfectly fine. The key is that x's are under x's and y's are under y's and constants are under constants. And that's exactly what's happening on this one. Now the next thing that we look for is we look to see if we have any variables that have the same or opposite coefficients. And so if you look right here, if you see that I have 3x, negative 3x right there, let me make it a little bit different color, negative 3x right there, and a positive 3x right there. Both of my x's have opposite coefficients. One's a negative 3 and one's a 3. That is quite lovely because we can then move on to step 3. If the coefficients are opposite, then we're going to add the two equations together, and that will end up eliminating one of the variables. So let me show you what I mean. We're just going to take this, draw a line, and we're going to add the top equation to the bottom equation. So when I add negative 3x plus 3x, I get 0, right? Negative 3x and a positive 3x is 0. Look at that, I've just eliminated that x. 4y plus a negative 6y gives me negative 2y. And 12 plus 18 gives me 30. So now I have negative 2y equals 30, and voila, just like a magician, I have made the x disappear. It's just gone. So I can solve for the y. Divide by negative 2, and I get y equals negative 15, just like that. Now, the next thing that I want to do is, actually I should have done in the very beginning, is just go over here and say, remember, I'm always solving for the x and the y. So I've just found out the y is negative 15, and now, using that same trick that I learned in substitution, I can take the negative 15 for y and I can replace it for one of the y's in one of these original equations. So I'm actually going to probably choose this one. And that's mainly because I've got negative 15 that I'm going to have to multiply 4 times, and that's easier than multiplying it 6 times. So I'm going to rewrite my equation, 3x, this time I'm keeping the x, but instead of y, I'm going to put negative 15. So 4 times negative 15 equals 12. And now I'm going to solve for x. So I have negative 3x. I'm going to multiply 4 times negative 15. Well, 15 and 15 is 30. So 2 times 15 is 30. So that means 30 and 30 would be 4 times 15. So that's 60. It's a negative 60 equals 12. And then I am going to add 60 to both sides. And I get negative 3x equals 72. And I have to divide both sides by negative 3. And I get x equals, let's see, negative 3 goes into 7, negative 2 times, with 1 left over. 3 goes into 12, 4 times, I think I did that right, 24 and 24. Let's see, and 24 makes 72. So x equals negative 24. Now I can check myself by taking negative 24, putting it for x, and negative 15, putting it for y, and making sure that it's true in both of these statements, both of them. So I already did the first one. So what if I did the second one? 3 times negative 24 is we just figured out is 72. So that would be negative 72. So I'm just going to write over here negative 72 minus 6 times negative 15. So 6 times a negative 15 equals 18. So 6 times a negative 15 should be another 30 onto 60. So that should be negative 72 minus negative 90. If I'm doing my math correct. And that should be equal to 18. Well, this negative 72 minus a negative 90 ends up being plus a 90. So 90 minus 72 is 18. So I get 18 equals 18. So I know that my my two variables, x negative 24, y negative 15, is a true statement for both my first one and my second. So that is the solution. That is where my two lines intersect. It's the point, the x and the y, that they both have in common. So that's a lot easier. That's easier than graphing for sure, because graphing getting way over a huge piece of paper with negative 24, negative 15 would be crazy. Even simpler than using substitution, because substitution would mean that I'd have to isolate one of those variables, which means I'm dividing, I'm doing all kinds of crazy things. So elimination works really nicely, especially when I have two variables that are opposites, because then all I have to do is just add them. Let's try another one. Let's try this one right here. 4x minus y equals 12. Well, actually, before I do that, let's go back to my little list here. So we stopped at, do the variables have the same or opposite coefficients? If the coefficients are opposite, then add the two equations together, which will eliminate one of the variables. We did that. This number 4, if the coefficients are the same, then subtract one equation. We're gonna wait and do that one later, because in this situation the coefficients were opposite. Then we solved for the remaining variable. We went back and we plugged the known variable into an equation to solve for the other variable. So that's what we did. So now let's look at this one. 4x minus y equals 12 and y equals 14x plus 18. There's one thing that we need to do first. If you look at our first number 1 step, it says line up the two equations so that the variables and constants match up. Well, right now I have 4x and I have a y underneath it. I have y and I have an x underneath it. I have 12 and I do have an 18 underneath it, but I have an equal sign over here and I have an equal sign over here. So these two equations are not in the same format. We have to get them in the same format. So I'm looking at it, and I think what I'm going to do is I'm going to go ahead and move my 14x. Just going to subtract 14x from both sides so that I have negative 14x plus y equals 18. See how I did that? See how I just moved my 14x over? I just subtracted it so that I put it on the same side as the y. And the reason is because eventually I want my I'm looking at this and I'm thinking that I'm going to be eliminating my y's. So when I take this 4x minus y equals 12 and I add to it negative 14x plus y equals 18, what do I get? Now I'm just going to write it over here, if that's okay with everybody. I'm going to write, and I'll keep it in the orange. 4x minus 14x is a negative 10x. Negative y plus y is 0. And 12 plus 18 is 30. So my 0, I've eliminated my y's, which is exactly what I wanted to do. Now I just have to solve for x. So I'm going to divide by negative 10. And I get x equals negative 3. Let me go back over here. Make sure that I have my x and y. I'll put this up here. I'll move this down a little bit. X and y, and my x is negative 3. Now let's go ahead and solve for y. Now I know that x is negative 3, so I'm just going to take that negative 3 and I'm going to pick one of these equations, either this one or this one, and I'm going to replace the x with -3 so that I can solve for the y. I'm thinking this one's easier just because I like multiplying -3 times 4 instead of 14. Seems a lot easier. So I'm just going to rewrite the equation up here. I'm going to say 4 times -3 minus y equals 12. 4 times -3 is a -12 minus y equals 12. I'm going to add 12 to both sides, and I get -y equals 24. Now, -y is close, but not quite. I need that to be a positive y. So I'm going to multiply both sides by -1, and I get y equals -24. So this time my y is -24, and my x is -3. I could check those and see if they came out correctly by plugging in the -3 in for x and the -24 in for y. And I'm looking here, and we already did this one up here, so let's do this one down here. -24, let me use a different color. -24 equals 14 times -3 plus 18. Well, I still have to figure out what 14 times -3 is. Let's see, -3 times 4 is 12, and then 3 times 1 is 30, plus that extra 10, so that would be a -42 if I did it correctly. I'm going to add 18 to that, which means I'm going to subtract 18 from there, and that gives me a 4. That gives me a 20, and it's a -24. -24 equals -24. It worked. Hooray! So, again, this is pretty fun. Elimination's fun. I love eliminating variables. So, now, let's talk about what happens when our coefficients are not opposite. This number 4, if the coefficients are the same. So, let's look at this first one down here. 4x plus 2y equals 28. 4x plus 3y equals 18. Well, the first thing I need to do is make sure that my two equations are lined up, and they are. The x's are under the x's, the y's are under the y's, the equals under the equal, the constants are under the constants. Now I'm looking to see if my coefficients are opposite or if they're the same. Well, they are the same. I have two that are the same. Do you see them? The 4x and the 4x. Because they're the same, if I tried to add them, I would just get 8x. So that's not going to help me. Instead, I'm going to need to subtract my two equations. And we can do that two different ways. We can either think about subtracting the bottom one from the top one, or we can think about adding the two after we've multiplied the bottom by -1. So either way works. The key to this is that you must remember that you're not just subtracting the x's, you're subtracting everything. So I'm going to go through and I'm going to say that if I subtract the bottom one from the top one, it means that this one is subtracted, this one is subtracted, and this one is subtracted. Okay? Every single thing on the bottom gets subtracted from the top. So let's go ahead and do it. 4x minus 4x is 0. 2y minus 3y, or plus a -3y, gives me -y. 28 minus 18 gives me 10. So y equals 10, but I need to multiply both sides by -1, so y equals -10. All right? I put it right over here. My little color wand out of the way. I'll put it right there. x and y, and I've said that y equals -10. Okay? Now I need to figure out what x is. So I'm going to take y equals -10, and I'm going to put it in place of one of these y's. I'm just going to choose this one. Really doesn't matter which one you choose. We always go back and we check them anyway. So, but I always like the easy. So I'm going to write, use a different color, 4x plus 2 times -10 equals 28. 4x plus 2 times -10 is -20 equals 28. Add 20 to both sides, and I get 4x equals 48. Divide by 4, and I get x equals 12. So x equals 12. Now, I can double check these and make sure that they're accurate. I've already done the first one. I've plugged in an x and I got the y. Now I could try the second one. I can either do it with all the negatives or I can do it without the negatives, but I'm going to go back to the original equation. 4 times 12. 4 times 12 is, I'll just write it right over here, 4 times 12 plus 3 times -10 should equal 18. 4 times 12 is 48. 3 times -10 is -30. 48 minus 30 is 18. 18 equals 18. It works. So 12, -10 is the place where the two numbers intersect. The two lines intersect. All right. Let's do this last one. And actually, I think I'm going to have you work on it first. So I want you to notice first which of the two variables are the same or opposites. And you can see right away that it's the x's. And now you're going to, actually I don't think I'm going to have you do this yet. We're going to work on it a little bit. I want to show you one other way to do this. And that is I end up, it's really the same thing with adding. When I don't really like subtracting, I like adding the opposite. So what I typically do is instead of subtraction, I always add the opposite. So I take this bottom number and I multiply it times a -1 so that I end up with x equals -3y plus 7. I keep that one the same. And then I add -1 times x is -x, and -1 times 6y is -6y, and -1 times 16 is -16. It's an equal sign. And then I just add them once I get all my negatives. So this becomes 0, this becomes -9y, and this becomes 7 and -16 plus, let's see, -9. Now, I have 0 equals -9y plus 9. Why don't you go ahead and finish the problem and solve for y? Solve for y and see what you come up with. Okay, so how'd you do? Did you add the 9 to both sides and end up with 9 equals -9y? Divide by -9, and you get y equals -1. I hope so. Let's go ahead and put it over here. And we'll say y is -1. Now you go back and you pick one of the two equations, plug -1 in for y, and see what you come up with. So How'd you do? Which one did you pick? I'm going to pick this one just because I like easy numbers. So let me change colors here. I'm going to put x equals -3 times -1 plus 7. Y equals -3 times -1 is a positive, or x equals +3 plus 7, x equals 10. X equals 10. Now, if you happen to use the other one, you can still do it. So let's do that one as well. We'll say x equals 6 times y is -1 plus 16. We've got x equals -6 plus 16. -6 plus 16 is a positive 10. X equals 10. Works either way. So that's how you solve with elimination. Now, elimination, you're either adding or subtracting. And when you're subtracting, you might still be adding. You're just multiplying everything by -1. The key is that you have to remember to subtract or multiply by -1. You have to do it to the entire equation. You can't just do it to the variable that you're trying to eliminate. Whatever you do to one part of the equation, you have to do to everything. So if you're subtracting everything. If you're multiplying by -1 and adding, you're multiplying everything by -1 and adding. Also, don't mix and match -1s and subtracting. You're either subtracting or you're multiplying by -1. Okay, so that's how you solve by elimination. There's a second part, a backside to this, which is a separate video, which we're going to talk about what do we do when we don't have matching variables that are either the same or opposite. Then we've just got to do a little bit of manipulation. It's pretty fun. So you'll want to watch the next variable because those are the more complicated ones. But just get this down and you'll be fine, and then be ready to watch the next one. Don't forget to write out a key idea, something that you want to remember that will help you to remember what to do when you're solving with elimination. And I'll see you in class.